Good morning, sir.
Good morning, sir.
Yes, good morning.
Good morning.
Good morning, sir.
So, in the last class, we are discussing different types of counters. So today we are going to see the another topic, which is shift registers. Are you able to see the whiteboard?
Yes, sir.
Yes, sir.
Okay. Okay. So today we are going to see the shift registers. Okay. So what are registers? Firstly, what is meant by register? Here,
जो 1 bit डाटा को स्टोर करता है
yes. So not necessarily that 1 bit data को store करेगा. That will depend upon the size of register. Okay. So different types of microprocessors include different sized registers. Okay. जैसे आप लोग पढ़िएगा 8085 माइक्रोप्रोसेसर, 8086 माइक्रोप्रोसेसर. Okay, so all the microprocessors will have different types of or different sized registers are there. Like the register may be an 8-bit register, okay, a 16-bit register. Okay, so there are different types. So based upon the size of the register, you can store the number of bits over there. Okay, so now so all of you know that register is nothing but a storage device. Okay, so and these registers, so registers are what? Registers are the storage elements. Storage elements. Okay, so what are these made up of? These are a group of flip-flops. Okay, so as we already know that one flip-flop can store a 1 bit of data. Okay, it is a flip-flop, so one flip-flop will store a 1 bit of data. So this register will include store a number of bits, and that will dependent upon the number of flip-flops. Okay, so if we have an n-bit word, okay, so if we have an n-bit word, okay, so for storing this n-bit word, what we need? We need
n number of flip flops.
yes, we need n number of flip-flops to store n bits of data, and we have already seen that one flip-flop stores 1 bit.
1 bit of data.
Okay, so if we want to store n bit word, then we need n number of flip-flops. Okay, so now based upon the movement of data or shift of data, so here the name is given that shift registers. So the data may be the data is shifted from one flip-flop to another flip-flop, and they are get stored. So the shifting may be of different types. Okay, so here what this shift register will do, that this shift register will have the capability to shift its binary information. Okay, so shift register के बारे में अगर हम कहें, so ये क्या है? Shift registers are able to shift its binary information शिफ्ट रजिस्टर्स क्या करते हैं, ये एबल हैं क्या करने के लिए, शिफ्ट इट्स बाइनरी इंफॉर्मेशन। तो अभी जो शिफ्टिंग है वो शिफ्टिंग कहां से हो सकता है, दैट शिफ्टिंग में बी फ्रॉम सॉरी लेफ्ट टू राइट और राइट टू लेफ्ट। ओके, और इस तरीके से हम डेटा को शिफ्ट कर सकते हैं या सेव कर सकते हैं। ओके, सो अगर दैट शिफ्ट रजिस्टर इज शिफ्टिंग द डेटा फ्रॉम लेफ्ट टू राइट, अगर लेफ्ट टू राइट शिफ्ट कर रहा है तो हम उसे क्या कहेंगे, अगर वो लेफ्ट टू राइट शिफ्ट कर रहा है तो इसका मतलब क्या है, राइट शिफ्ट हो रहा है, सो इट इज नोन एज
राइट शिफ्ट रजिस्टर।
राइट शिफ्ट रजिस्टर। और अगर लेफ्ट शिफ्ट हो रहा है तो हम कहेंगे लेफ्ट शिफ्ट रजिस्टर। ओके, सो
यस सर।
यस, ऑब्वियस है कि जो भी ये शिफ्टिंग होगा, दैट शिफ्टिंग विल डिपेंडेंट अपॉन द क्लॉक पल्स। हम जानते हैं कि हमारा जो फ्लिप फ्लॉप है वो एक क्लॉक फ्लिप फ्लॉप है, सो द शिफ्टिंग विल बी बेस्ड अपॉन द clock pulse. Okay, now based upon the shifting also, किस तरीके से डाटा एंटर किया गया है, बेस्ड अपॉन दैट क्लासिफिकेशन based on what, the data entered or retrieved. Okay, so based upon the data entered or retrieved, there will be 4 types. So the shift register is divided into 4 types as okay, let us see all those 4 types. So type 1, type 2, type 3 and type 4. What are those types? We can see. Okay, so the very first type is known as CISO. I will tell you the full form of all these, and I think some of you also know this. Second one is SIPO. Third one is PISO, and fourth one is PIPO. So here, what this SISO represents, this SISO is nothing.
Single input, single output.
Yes, this is serial in, serial out. Second one is serial in, parallel out. Third one is
Parallel in.
पैरेलल इन और सीरियल आउट।
in, serial out, and last one is
Parallel in, parallel out.
पैरेलल इन पैरेलल आउट।
parallel in, parallel out. Okay, so based upon the, so in the first case where we have serial in and serial out. So as the name suggests, all the data will get input serially, and serially we will get the output. Okay, so how we can represent that? So let us assume there is a 4-bit or 4 flip-flop register is there. Okay, so we have a 4-bit register. I am drawing just a block. Okay, so okay, let me draw firstly 4 blocks. So will it get converted? Yes. So can I copy it? Is it possible?
Yes, sir.
Let me try it. Yes, copy. Oh, how I can take it from there? So it will take more time. Let me draw it. Let me draw that. So I am drawing. Okay. 4, simply a block in which I will show 4 flip-flops. Okay, so here I have drawn a block which consists of 4 flip-flops. So it will have 2, 3, and 4. Okay. So in the first case, as the name suggests, serial in, serial out. So serial in, serial out means what? That if we are giving an input in the first flip-flop, so this is the flip-flop 1, this is flip-flop 2, this is flip-flop 3, and this is flip-flop 4. Okay, so here if we will put data over in the first flip-flop, then serially we are putting the data bits serially, and we will get the output serially. Okay, so in this case, if we have a 3-bit data, okay, if we have a 3-bit data, let it be 1010. So firstly this is 0 here. So when the first clock will come, when the, so as I have taken the 4 flip-flops, so we should have a 4-bit data. Okay, so if the first bit is here, and this first bit will be, okay, so in this case we have 4 bits, and in this 4 bits this is the LSB and this is the MSB. Okay, so we will see it later. We will see it later when we will discuss all these flip-flops in elaborative way. Okay, so this is the example, or this is the block diagram for serial in, serial out, where here it is the input and here it is the output. Okay, next we will have a serial in, parallel out. So how we can draw this? We have a 4 flip-flop combination. This is a flip-flop 1, flip-flop 2, flip-flop 3, and flip-flop 4. So here, as the name suggests, serial in, parallel out. So data will feed into the first flip-flop, and we can get data from the output from all the flip-flops parallelly. Okay, So to store the data in all the flip-flops, we need 4 clock pulses. If we have a 4-bit data, so in 4 clock pulses, we can store the 4 bits, and we can get the data parallelly. Okay. So here there are the outputs, and here it is input. In the next case, we have a parallel in, serial out. So what will happen here? We will apply the data in all the flip-flops parallelly. Okay, so this is flip-flop 1. So data will get entered in this flip-flop, in this flip-flop, in this flip-flop, and in this flip-flop parallelly. Okay, so these are the input here, and as the name is suggesting, parallel in and serial out. Okay, so data will get output from here. Okay, so here it is the output. In the next case, as we can see, parallel in and parallel out. So I think all of you can see or you can think that how will be the input and output. So flip-flop 1, flip-flop 2, flip-flop 3.
Left in, right out.
Yes, flip-flop 4. So in all the flip-flops, we will have the input as a parallel input. That is, in all the flip-flops, the input will get introduced, and from all the flip-flops, we will get the output in parallel manner. Okay.
Yes,
so
sir.
from all these diagram, you can conclude that in which system we will consume least time.
So fourth में.
Sir,
Fourth
PIPO.
Yes, it is quite obvious from this picture that in the last case, that is in PIPO, we will that the time consumed will be least. Okay. So now, one thing you should know, and it is asked in exams also, that we give 2 different names to the serial form and the parallel form. So serial form, जब हम data को enter करते हैं, then that is known as, so when data is entered in serial form, then it is known as temporal code. Okay, and on the other hand, when the data is in parallel form, it is known as spatial code. Okay, so this you should know. This is VVI. This is generally asked in exams also. So serial form, also known as the temporal code, and parallel form, it is known as the spatial code. Okay, so अगर आपको ये नहीं पता होगा तो आपको पूछ दिया जाएगा that how we can convert an spatial code into temporal code, and from temporal code to spatial code. So at least you should know that what this temporal code and serial code. Okay. So now in the case, let us take all these 4 cases, and we will understand the first case only in elaborative way, and I think all of you will understand the thing for the other cases also. So let us take the first one, the CISO. Okay, so I think all of you know that what this CISO is: serial in and serial out. Okay, so
Yes, sir.
if we want to construct a 4-bit or a 4-bit write shift register, okay, so we are going to draw a 4-bit Why it is not writing? Four. Okay, yes. 4-bit write shift register. Okay, so if we want to have a 4-bit write shift register, then obviously we should have a 4 flip-flop should be there. 1, 2, 3, and 4. So I am doing it very roughly. Okay, so we have a 4 flip-flops. So the app is working somewhat slowly. So we have here D flip-flop. Okay, so it is D3, D2, D1, and D0. Okay, and we have as we are going to study a 4-bit write shift register. So whatever input we will feed over here. Okay, so and this flip-flop is for, yes, one thing we have to give in all the flip-flops is the clock pulse. I think I should change the color so that it will be more visible to you all. Okay, so we have connected the clock to all the flip-flops, and we have the input as input data. So here we have the Q3 bar, Q2, Q1, and Q0. Okay, so as it is a shift register, so what it will do, it will just shift the data to the next flip-flop. And here, so here we will apply the input, and from here we will get the output. Okay, so let us take an example that if we have a data as 1, 0, 0, 1. Okay, so if we have this type of data, or instead of this, let us take this data 1, 0, 1, 1. Okay, so in this case we know that this is the LSB and this is MSB. Okay, so what we will do here, so we will start introducing the LSB bit first. Okay, so if we will introduce this LSB bit first, so let this bit as this is B0, this is B1, this is B2, and this is B3. Okay, so firstly we will put the LSB bit into the register. Okay, so we will put a 1 here. So okay, so let us write it here also. So initially all the flip-flops are reset. Okay, initially all the flip-flops are reset. So this is Q3, this is Q2, this is Q1, and this is Q0. So and the data we have is 1, 0, 1, 1. So what will happen here? I am putting here the clock CLK. Now what you can see, the page is not going upward. Yes, so here in the clock pulse 1, okay, I am taking the first clock pulse. So in the first clock pulse, what will happen? We have a data input here as 1. Okay, as what I have already told you, that the first bit or the LSB bit will get introduced at the input. So when the first clock pulse will come, what will happen? this 1 will come over here, that is Q3 will become equal to 1, and what will happen? Whatever is introduced at Q3 will come to Q2. Okay, so this 0 will come here. Okay, this 0 will come here, and this 0 will come here. Is it okay to you all?
Yes, sir.
Yes,
So,
sir.
as this, all of you know that this is a D flip-flop. And what is the work of D flip-flop? D flip-flop transfers whatever we have input, transfer it to the output. Okay, D flip-flop just do that. So this is the case for the first clock pulse. Okay, in the next clock pulse, what we have the next data bit as this 1, B1. Okay, so this is B0, this is B1, this is B2, and this is B3. Now we have B1 at the input. What is B1? B1 also is 1. Okay, let me change the color. So in this second clock pulse, so when the second clock pulse will come, what will happen? Whatever the data input we have introduced here, so the next bit is also 1. So then this next bit will come at the input. So whatever at the input, it will transfer to the output Q3. So we have introduced a 1. Okay, now this one, okay, so whatever 1 is present here in the previous T state, it will transfer in the Q2. So this 1 will be transferred to Q2, that is 1 here. This 0 will transferred here, and this 0 will get transferred here. Okay, next let us take the third T state. So in the third T state, we will introduce this B2 at the input. Okay, so this B2 will come at the input of D3. So when the third clock pulse will come, this input 0 will come into the output, that is Q3. And whatever the value at Q3 will come to Q2. So this will come to Q2. This will come to, sorry, Q1. Okay. And this will come to Q0. Okay. Now the next bit is 1, that is B2, sorry, B3. So this in the next clock pulse, we will have B3 में जो input देंगे, that is B3 जो input है, that is 1 है. So D3 पर 1 जब input करेंगे, तो next clock pulse में यही input क्या हो जाएगा, output में transfer हो जाएगा, means Q3 will become equal to 1, and this 0 will get transferred over here. This will get transferred over here, and this will get transferred over here. So what we can see now, the data we will have is 1010. Okay. So अभी हमारे पास जो आउटपुट है वो क्या मिला है, अभी जो हमारे आउटपुट है, जो यहाँ पर स्टोर्ड आउटपुट है वो क्या है, Q3 पर 1 है, Q2 पर 1 है, सॉरी 0 है, D1 पर 1 है, और सॉरी Q1 पर 1 है, और Q0 पर भी 1 है. ओके, so we can see that at all the flip flops we have got the output as 1011, जो कि हमारा डेटा फीड करना था, वो डेटा ऑलरेडी फीड हो चुका. ओके, so we have fetched the data in serial form. Now we have to get the output in serial form. So when we will apply the next clock pulse, so अभी जो clock pulse है हमारे पास आउटपुट में एक पहला ये डेटा बिट हमारे पास आउटपुट में है ऑलरेडी. ओके, now when we will apply the next clock pulse, what will happen? In the fifth clock pulse, अगर हम यहाँ पर 0 पुट करते जाएं इनपुट में, और हमें ये डेटा आउटपुट में चाहिए, हमारा ये चारों का चारों बिट, तो पहला बिट तो ऑलरेडी हमें आउटपुट में मिल रहा है, जो कि LSB वाला बिट है. ओके, so this LSB bit will come over here. Next we want this one at the output. So what we have to do, we have to shift this data at the output. So we will apply a next clock pulse. So here we will have a 0. Next this 1 will come over here, this 0 will come over here, this 1 will come over, sorry, this is 0, this 1 will come over here, and this we already have the output. Okay, so next we have got the output as this one. In the next clock pulse, what will happen? This 0 will shifted over here, this 1 will shifted over here, this 0 will get shifted over here, so we will get the output here, this, and next we have got this 0, and in the next clock pulse, okay, so it is not going, okay, yes. So it is working somewhat slowly. So in the next clock pulse, that is in 7th pulse, what we will have? We have this, we already got 1 0 0. Now in the next clock pulse, so let us take a 0 here. Oh my God. So we have the 7 here, 7th clock pulse. Here we will have a 0. Now this 0 will come here, this 0 will come here, this 1 will come here, and we will get the output. Okay, so what we have seen that in this flip-flop, what we are getting data which is at the output. Okay, so this was the initial state, and if we apply one more clock, then what we will get? 0 0 0, and this 0 will come here. Okay, so in this way, in all the 8 clock pulse, so we have started from this, and we have got this. So in this case, we have seen that if we have n bit of data, then n clock pulses are required to save the data in the flip-flop, sorry, in the register. Okay, that we have to see. Here, one thing I want to note you that the flip-flop which is very on the right side is known as the LSB flip-flop. As we can see that this one is the LSB bit and this one is the MSB bit. So this is the MSB flip-flop. Okay. So this is all about the CISO, that is serial in, serial out shift register. In the same way, if we have to see the serial in, parallel out shift register, then what we will do? So for the all the four bits, we need 4 clock pulse to feed the data. That is, if we have the same combination of bit, that is 1010 1011. So in 4 clock pulse, we will have the output. Sorry, we will have the all the 4 bits are stored, and as if we are taking as serial in parallel out shift register, so in that case, what we will get? So we will get the data parallelly at this Q3, Q2, Q1, and Q0. Okay. So in this case, we need only 4 clock pulses to get the output. Okay. So I think all of you can see the difference, that all of these are differ in this manner only. Okay. So in this case, so in the first case, that is in serial in, serial out, serial in, serial out के केस में हमें n clock pulse लगेंगे आउटपुट लाने में. ओके, और n क्लॉक पल्स लगेंगे हमें आउटपुट को वापस से बाहर लाने के लिए. ओके, सो अगर हमें फ्लिप फ्लॉप को अगर क्लियर करना हो फिर से, दैट इज इस रजिस्टर को अगर हमें फिर से क्लियर करना हो, तो हमें 4 क्लॉक पल्स और लगेंगे आउटपुट को सारे इस फ्लिप फ्लॉप को क्लियर करने के लिए. ओके, बट इन दिस केस व्हाट यू कैन सी, in this case what you can see that in 4 clock pulses we are saving the output, as well as in the 4th clock pulse we can get the output at all the flip flops. So इस केस में अगर हमें फीड करना हो और आउटपुट निकालना हो, so here we can see that a total of n minus 1 clock pulses are required. So what is n here? What is n here? What is n here?
Mod, sir.
No. Here n is not mod. Here n is representing
Number of
just the
flip-flops, sir.
number of flip-flops. N is the number of flip-flops. So in serial out shift register, if we have n bit of data, so n clock pulse are required to store the data, and n minus 1 clock pulses are required to get all the outputs. Okay, serially. Next, we will have the parallel in serial out. So in the case of parallel in serial out, we will give input to all the flip-flops parallelly, and we will get the output in the serial form. Okay. So only this much is the
सर 4 बिट डेटा आउटपुट के लिए 8 क्लॉक पल्स चाहिए होगा
4-bit data
आउटपुट के लिए 8 क्लॉक पल्स चाहिए होगा
नहीं 8
और
clock
सर
8 clock
8 इनपुट भी तो देना पड़ेगा हम लोग को 4 आउटपुट के लिए
तो मैंने यहाँ पर अभी क्या कहा देखो, जैसे यहाँ पर हमने 4 बिट का जो एग्जांपल लिया ना,
हाँ सर
हमने जो 4 बिट का एग्जांपल लिया है, तो डेटा को सेव करने में, उस पूरे 4 बिट डेटा को सेव करने में हमें कितने क्लॉक पल्स लगे थे?
8 क्लॉक पल्स सर सेव करने के लिए 4 लगा था सर
4 लगा, ठीक है। अभी उन चारों बिट को अगर हमें बाहर निकालना है, दैट इज Q3 पर लाना है, सॉरी Q0 पर लाना है, तो कितने बिट्स और लग रहे हैं? आप देखो यहाँ पर हमें आउटपुट मिलना यहाँ से शुरू हो गया, तो टोटल कितने बिट्स एक्स्ट्रा लगे, कितने टी स्टेट्स एक्स्ट्रा लगे?
3 स्टेट एक्स्ट्रा
Sir.
लगे
आप लोग फिर से ज्वाइन करो, सेशन इज गेटिंग ओवर नाउ।
Okay, sir.
So here